Welcome to the continuation of Lesson 3, where today we will look more closely at how we can determine the relative likelihood of the FH mutation being passed on to multiple members of your family, whether that being your children or your siblings. Here again, I want to reiterate a couple very important points. Each instance of inheritance is an independent event, meaning that one family member's genetic inheritance bears no influence on another family member's genetic inheritance. The important point being, the odds for inheriting an autosomal dominant disorder like HLRCC is always 50-50. And that's simple enough. However, when you have multiple independent events, like having two or more children, the overall probabilities get a little more complicated and the results are often not at all intuitive. And so it's critical to really break down how the math works out. And the reason why I feel this topic is so important is because it's not unusual to see parents with genetic diseases question how it is that most or even all of their children were unlucky enough to inherit their disease. Oftentimes, this question is being conveyed along with a lingering sense of guilt, as if there was possibly something they did wrong to bring about such misfortune. If you have ever had these thoughts, rest assured the inheritance of genetic disorders like HLRCC is purely a matter of chance. And outside of in vitro fertilization and pre-implantation genetic testing, there's no way to influence these outcomes. However, what we can do is better understand how these odds play out and just how likely or unlikely it is to expect certain outcomes. Let's start then with an example of a family of 4 children. What are the odds of all 4 inheriting HLRCC? In order to find this out, we need to multiply together each individual child's probability of inheriting HLRCC. So since the chances of any child having the mutation is 50%, that means we'll multiply 0.5 times 0.5 times 0.5 times 0.5, and this is going to give us an answer of 0.0625. Now to turn this into a percentage, we're going to have to multiply that number by 100, which moves the decimal place over 2 spots to give us a final answer of 6.25%, meaning that a family of 4 can expect to have all 4 children have HLRCC 6.25% of the time. Now obviously there are many other possible permutations, and by permutations I mean all the different ways in which a group of things can be arranged together, meaning sometimes you'll have a family with 2 positives and 2 negatives, or 3 positives and 1 negative. And so let's make a chart showing all these different possibilities and the odds or percentages that go along with them. In our first example, all 4 kids had HLRCC, which again, we can see them as highlighted in red right here. So then in our first column of number of kids with HLRCC, we're going to put 4. As far as the number of permutations, since there's only one way to arrange this type of sequence, there's only one permutation. And we already saw that the odds was 6.25%, but if we look at that as a fraction, that turns into 1 over 16. So far, so good. That's pretty straightforward. But what about the odds of having 3 out of 4 kids with HLRCC? In this case, there's more than one way to order the groups. Multiple permutations means we can no longer just multiply the individual probabilities like we did in our first example. So let's chart it out and see how we go about figuring out these different percentages. In this case, let's start by saying the firstborn has no mutation, but the following 3 children are positive. We can continue to show the other possible permutations. In this case, the second-born is negative, in the third case, the third, and so on in the fourth. All told then, we see that there are 4 ways to arrange this example. 1, 2, 3, 4. But then how do we go about finding the odds of having 3 out of 4 kids with HLRCC? First, we have to find out the individual probability for each permutation. So just like before, we're going to multiply 1/2 times 1/2 times 1/2 times 1/2. And that gives us 1 over 16, no surprise there. But we're going to do that for the other 3 permutations as well. Now, since there are 4 ways that this can happen, we need to add up those 4 individual probabilities together. And when we do that, we see our answer is going to be 4 over 16. Or in this case, 1/4 or 25% of the time, a family of 4 is going to have 3 children with HLRCC. So then what are the odds of a family of 4 having 2 positive HLRCC cases? Let's run through the possibilities. Here then we can see there's going to be 6 permutations, or 6 different ways that we can arrange these positive and negatives. And just like before, we're going to find out those individual probabilities. And now because there's 6 permutations, we're going to add all 6 together. So 1/16 added 6 times, you're going to get 6 out of 16, which translates into 37.5%, meaning that 37.5% of the time, a family of 4, 2 of those children are going to be positive and 2 are going to be negative. Even after learning how these probabilities play out, every bone in my body wants to say that this should be 50%, but it's simply not. And this is a great example of how instances of probability often escape our natural intuition. But let's continue and complete our entire chart. And then we can see the remaining parts are going to mirror the first two parts, but up until now, we've only looked at how to find the odds of having exactly so many positive cases. But we can also look at the cumulative probability, or the chances of having more or less than a certain amount. Take, for instance, what are the odds of having 2 or more kids with HLRCC? In this case, then, we're going to look at group 2 and everything above it. So in cases where we have 3 kids with HLRCC, and even the last case where all 4 have it. And when we look at those probabilities, we'll add up the odds of each group. So 1/16 plus 4/16 plus 6/16, and we'll get a total of 11 over 16, or 68.75% of the time, you can expect a family of 4 to have 2 or more kids with HLRCC. Conversely, the odds of having 1 or less would be 4 over 16 plus 1 over 16, or 5/16 of a time, or 31.25% of the time, you'd expect 1 or less kid to have HLRCC. And just so there's no confusion, if I had asked what the odds of having 2 or less kids with the mutation, you would still get 68.75% of the time to have 2 or less kids with HLRCC. And the reason this is the same and the two totals of the more or less than 2 add up to over 100% is because we've included this group of 2 twice in that case. But let's move on to probably the most informative question we can ask ourselves. What's the likelihood of a family of 4 having at least one of the children being positive for HLRCC? In this case, we would add up everything above this final row here. And when we add up all those different permutations, we're going to see that the odds are going to be 15 over 16, or 93.75% of the time, a family of 4 can expect to have at least one child with HLRCC. That being said, they could have 1, they could have 2, they could have 3, or they could have 4. It includes all of those options. Moving on, we can look at how a family of 3 would look and how the chart changes. So instead of 4, we now have 3 babies in each section. And instead of everything being out of 16th, our fraction is now out of 8. And when we count up the permutations, we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 total permutations total, which is why the denominator is out of 8. So then what are the chances of at least one child with HLRCC in a family of 3? We're adding all these permutations together. So 1/8 plus 3/8 plus 3/8 means 7 out of 8 times, or 87.5% of the time, a family of 3 will have at least one child with HLRCC, meaning that only 12.5% of 3-child families will have no children with HLRCC. And just like before, you can look at all the different options if you want using these charts. But moving on to a family of 2, again, our chart changes. Instead of out of 16 or out of 8, we only have 4 permutations, so our fraction is out of 4. So 50% of the time, you can expect to have at least one child with HLRCC. And then 25% of the time, both children will have HLRCC, or 25% of the time, you'll get lucky and have no children with HLRCC. Hopefully, looking at these charts helps you better understand how these probabilities play out. But if you just want to ever look this up on your own, you can Google a binomial calculator, because that's the type of probability we were doing. You'll notice there's this kind of complicated formula where you can plug in all the different numbers, but that's totally unnecessary because the calculator you can use allows you just input the data directly. So here in the first input box, it's asking for the probability of the success of a single trial. So it's asking what's the probability of each child being born with HLRCC, and that's going to be 50%, so we'll put a 0.5 there. In this example, let's say we want to look at a family of 5, so number of trials or number of children, we'll put 5 children. And then the number of successes, that's not the best word to use, but let's say the number of positive cases we'll get. So what are the odds of 5 children having HLRCC in a family of 5? We'll press the calculate button, which would be below this area here, and we'll see the probability of all 5 children having HLRCC is going to be 3.125%. So that's a rather low probability, but by no means impossible. We can then use this cumulative probability to answer what are the chances of at least one of those 5 children having HLRCC, and we'll see that 96% of the time you'll have at least one child with HLRCC in a family of 5. And I also wanted to point out that UCLA is starting a clinical trial for patients with metastatic HLRCC kidney cancer that have progressed beyond the standard therapy. I've put a link to this trial information in the description below, and I'll also add his email address if you want to reach out to him personally. And again, the UCLA group is one of the best in the world at treating HLRCC, so it's definitely within your interest to check them out and see what they can do to help you. Thanks again for watching. Hopefully my next video will be out shortly, and I'll see you then.